Hello, I'm Kotera from Makino Milling Machine. Today I would like to introduce INTERMOLD 2020 on the website. The exhibition INTERMOLD 2020 was supposed to be placed from 15th to 18th April. However, unfortunately, the show was cancelled. Because of that, we Makino prepares digital exhibition on the website as INTERMOLD 2020 on the website. There are 3 themes on the exhibition: Makino MES concept, automation, and facilitation. I would like to show what you can see on the INTERMOLD 2020 on the website, along with these 3 themes. The first theme is Makino MES concept. This is a production execution system against understaffing. Please see this video. This movie shows Makino's future concept to maximize capacity utilization of your factory. In Japan and in all over the world, there are no ways to avoid manpower shortage because of global population decrease. How can it be to produce same modes or more modes with less workers? In all fields of industries, digitalization and computer technology have been developed and introduced day by day. So, what Makino can suggest you to improve more efficiency on your facility? This is our suggestion. The system alters the daily schedule in real time to maximize factory's overall capacity. You may think this is futuristic, but artificial intelligence changes and analyze the schedule and take the best production method one by one. For example, after production system choose the best way of manufacturing, the robot with AGV choose the best tool from the tool database, then automatically put these tools into machining center. Such a simple labor are replaced from human to robot. Not only tools, but workpieces are also delivered by this AGV. If you have old machines which do not have automation door, do not worry about that. The robot opens the manual door, then set up the workpiece. We recommend to use 5-axis machining instead of 3, because single checking solves every machining on the process. This is Makino's target and future of production maximization. We are working day and night to introduce this system to customers. The system is not released yet. However, we keep working on to meet the customer's demands. That sounds like too futuristic and vast theme, but this is the Makino MES concept, production system against understaffing. Here is the second theme, automation. I made a subtitle as Inside Machine Measurement Enables Consistent Long Time and Precise Machining. The most important point of automation is not introducing robots and AGVs. The important point is machine itself can detect when the machining is neatly done. So I would like to explain milling operation, sinker EDM operation, and wire EDM operation. On these three machining, how Makino suggests the method of inside machine measurement. First is milling operation. This is IQ 500 micro machining center. This is very accurate machine, so can aim plus minus 1 micrometer accuracy. Not only the machine, but also workpiece measurement system and two measurement system are provided as option to secure the machine's accuracy. However, there is a problem. All these three machines and devices calibration depends on operator's labor. So some operators may hesitate to do that because all of responsibility of accuracy is on the calibration. Some less skilled operator even do not know what the calibration is. So we are thinking how we can automate this calibration. Here is the automation of calibration. You can see the sphere is attached on the table, and the sphere is attached on the sensor to detect where the center of workpiece measuring probe is. As I said before, some operators may hesitate to do the calibration because it takes lots of time and skill to realize high accuracy. However, Makino developed the software and hardware, which enables with single button press to calibrate all of the devices. But the calibration is very necessary step to achieve plus minus 1 micrometer. So it should not be depend on the operator's skill. Therefore, Makino developed our own technology to automate them. Now the machine changed the tool. Then tool measurement device detects the center point of the tool. Therefore, the machine can detect where the center point of the tool is to achieve plus minus 1 micrometer accuracy. The workpiece on the table is high hardness heat treated material SKD11, HRC is 60. This is a sample of microflow channel mode. This is a high speed cutting. The feed speed is F2000. The tool diameter is very small, 0.5 millimeter, and it is using CBN tool with radius R0.05. Now you can see this blue triangle. After automating the calibration of workpiece measurement device and tool measurement device, it enhances and withdraws the performance of accurate machining center. So you can realize more accurate machining and measurement. The next one is sinker Iridium. So this is our small sinker Iridium EDAF3. Especially this machine is popular for connector die industry, which requires very severe pitch accuracy. However, this machine has a problem. After machining, before the final finishing of 5 micrometer depth, operator stop the machining, remove the workpiece, then measure how much to machine more. Then adjust the arcing setting depending on the operator's skill, then reset the workpiece, then machine again. After repeating and repeating the cycle, it takes lots of time, and the skill is depending on the operator. So how can we realize the consistent depth accuracy? So this demonstration shows how Makino's machine detects the depth accuracy. So for example, the connector die, it only has 0.3 or 0.5 millimeter pitch on each peak of the mold. Therefore, the machine forms the probe by itself. You can see that this probe is approaching to the workpiece. It is very, very small diameter probe. Because this is sinker Iridium, it is not necessary to be physically contacted to the workpiece. If there are physical contact, the probe easily breaks off. Once the machine detects the conducting of electricity, the machine automatically detects how much depth are left to be perfect condition. After detecting how much to be machined, Makino has an experience of slightly additional machining. So if 5 microns, 3 microns are left, the machine automatically detects the value, then optimize the setting to make these additional machining. So you do not have to remove the workpiece one by one, and you can leave the final machining to this sinker Iridium. Therefore, automation of high accuracy is realized. Then machine automatically confirm if the workpiece machining is done or not. Finally, I would like to explain about wire Iridium machine. This is UP6 heat. This is so accurate machine that can aim plus minus 1 micrometer pitch accuracy. However, this machine also have a problem. Same as a sinker Iridium, the operator have to remove the workpiece, then measure it, and compensate the value of arcing. Then after repeating this remove and measure process one by one, the operator is aiming the final finishing of pitch accuracy. That means the pitch accuracy compensation depends on operator's skill. So, how Makino eliminates this manual adjustment? There is a visual measurement device attached on the machine's head, and the machine head moves the same path as the machining. The reason why we use visual measurement device is sometimes the workpiece pitch is too narrow, so the work measurement probe cannot get into the space. If this is why we adopt this visual sensor, and as I said on the Synca EDM section, we have a technology of slightly additional machining. So once the detection device tells there are 2 microns, 3 microns additional machining, the machine automatically adjusts the condition, then do this rest of job. So here is the cycle. You do not have to remove the workpiece from the machine. Inside machine measurement, on the picture there is a probe, so you can select whether the visual image sensor or the physical contact probe. And then after detecting how much to be machined more, machine automatically selects the best condition to make slight additional machining, then finish the workpiece. That means we automate the pitch accuracy compensation. So I introduced the 3 machines automation in terms of inside machine measurement. So I would like to introduce the last theme, facilitation. So no matter how we introduce the automation system, the final user of the machine is human. So we always thinking how we can make easy and friendly machines and technology as a mode making tool. This is our latest technology called Athena. You can see the demonstration of voice control. Operator tells the machine to unclamp the tool. Then the machine unclamps the tool. Even the operator's hand, both hands are occupied. You can manipulate the machine with voice. So not only the voice command, but Athena tells the operator which items to be set up. So especially for beginner operator, it is more easier to manipulate the job before pressing the start button. Next is the 5-axis technology. So there are lots of difficulty of 3-axis machining. The tool can be very long in this case, and the surface finish will be bad because of chattering, and also tool life become very short. So we recommend to use the 5-axis machine, which can tilt the tool to realize better surface quality. Also, the 5-axis machining makes your job more easier. For example, this is the video of D200Z, our vertical 5-axis machining center. What the machine is making is high-speed steel press die. The workpiece is 60 HRC, and the workpiece size is 20 × 100 mm. So the tool is PCD tool, sintered diamond. So this combination realizes the very beautiful mirror surface finishing on punching die. It is almost joke to make the same workpiece with 3 axes. So 5-axis machine expand your possibility on job. So you may think 5-axis machining is difficult. The most difficult point is making the program, I think. You have to avoid the collision of workpiece and machine, and also the 5-axis programming needs to have more experience to make. We have a solution. This is FFCAM, the Makino developed CAM software. It automatically converts the program from 3-axis to 5-axis with single button press. So you can utilize your existing 3-axis program into 5-axis program, then introduce to the 5-axis machine. Also, the biggest concern is taking time on the calculation. Makino's FFCAM has a solution of this. We have an ultra high-speed calculation system utilizing the cloud server for a calculation. So there is a comparison between the conventional calculation and cloud CAM calculation. So once the data is uploaded on the cloud server, the supercomputer processes the path conversion. It is uploading the data and converting the program to the 5-axis right now. Then downloading the data from the cloud server. So it only takes 2 minutes. So you can do the try and error as much as you want. On the other hand, the conventional method takes more time. Let's see how much it takes. 21 minutes. That means this ultra high-speed calculation system is 10 times faster than your computer's calculation. At the last, I would like to introduce teaching-less automation system, iAssist. On our previous exhibitions, you may see some demonstration, but let me introduce. So this is the iAssist overview. We connect the machining center and tool presetter and 3D measurement device. So this robot is cooperative robot which do not require safety fence, and this is an automatic ground vehicle, AGV. You do not have to make teaching. Only thing to indicate is move from point A to point B. After measuring the tool, the robot picks up the tool, then deliver to the machining center. So this simple labor is replaced from the human to this robot and AGV, iAssist. So this AGV has a radar to detect what is in front of the vehicle. So once the system detects a human or obstacle, it automatically avoids these obstacles and make their way. So such a complex system needs a very high skill of integration. However, they think by themselves. They are autonomous. So you do not have to spend such time, and you don't have to pay for integrator to introduce this system. So as you can see in the first video, the robot opens the manual door, what operator usually do. So that means you can integrate the old machine, existing machine, into this iAssist system. No matter the machine has automation door or not, this AGV and robot automates the workpiece setting. So after the machining, this robot picks up the workpiece, then deliver to the 3D measurement machine. As I said before, the key point of automation is confirmation of the result. If the system sees the workpiece is completed, it will be fine. But if it is not, iAssist picks up the workpiece, then set up on the machining center and repeat the cycle without humans' intervention. So this was the third theme, facilitation. Easy and friendly mold making tool. So I introduced three themes: Makino MES concept, automation, and facilitation. Also, we are going to exhibit ultra-efficient wire processing. Use 6 heat. What the ultra-efficient wire processing is, we adopt 0.4 millimeter diameter wire. The conventional wire thickness is 0.25. However, this 0.4 millimeter can cut twice faster than the conventional wire. No other wire Iridium competitor adopts this 0.4 because the wire is too thick and hard to feed inside of the machine. But we developed a new technology to enable to use 0.4 millimeter wire. For example, you can see the comparison. 0.4 millimeter wire only takes 100 seconds to cut the workpiece. On the other hand, 0.25 millimeter wire takes 200 seconds to cut out this workpiece. You can see the 200 seconds to cut the workpiece. That means this 0.4 millimeter wire is twice efficient than the conventional wire. So I repeat again, INTERMOLD 2020 on the website is now available. So do not forget to join the exhibition. Thank you very much and see you later.